to another episode of Coder Conversations. Today we have Jason Adam. How's it going, man?
It's going good. How you guys doing?
Not bad.
It's nice to finally, like, I guess sort of virtually meet you guys, because like I've been following both you guys for like quite some time on LinkedIn, and it's like chat, we like chat over LinkedIn and stuff. But like, it's cool to like finally like see you guys in person, sort of in person.
I feel like I could recognize you by the grammar, but now I can recognize you in person.
Yeah.
Yeah, it seems like we've all had like a couple of online sparring battles. Remember, we had the interview thing.
Yeah. I used to, LinkedIn's a funny place, like my wife always refers to it as like the man in the arena, where it's like I'm more than willing to like go back and forth with someone if they're respectful and they're willing to share their opinion. But like, a lot of people are afraid to share their opinion on there. And so, if you're not jumping in the game and sharing your opinion and your thoughts, like it's hard for me to like take them serious when they come try to bash me for mine, because it's much harder to like put your opinion out there for people to respond to than it is to react to someone else's. And so, that's kind of like the mindset I take it used to bother me, but now I'm just like, it's all right.
I sort of left for a while. I had left like being an IC because I wanted to get into teaching and training so I could produce the people that I wanted to hire. And so now I'm a CTO and I just produce them, through mentorship and promotions, I guess. Yeah. But I write online on LinkedIn and it's so hard to know who I'm going to upset and who I'm not, because I have strong opinions about like what works and doesn't, but it works for my team and my personality. It doesn't necessarily mean it'll work for yours.
Sure.
Or how you're set up. But sometimes I encounter people and it's like, oh my gosh, I definitely like upset that person. It's never my intention.
Yeah, same. I usually reread the stuff I write like maybe 4 or 5 times before I post it, because like I try to think like, well, I don't want to come off like too brash, or like I try to like at least like say, like, well, obviously this doesn't encompass everything, but I don't know. Someone always finds a way to get offended by it, so I think it's just part of the game. Yeah, I try to be careful about that because, yeah, I mean, like you said, my opinion is based on like what I've experienced, and like it may be completely different from how you've experienced things, and that doesn't mean that either of us are like wrong. It just means like we've experienced it differently. And so like one of the things I love about LinkedIn is like so many people want like an echo chamber, like, yeah, you're right, you're awesome. Like I like when someone comes on my post and is like you did the other day, and you're like, well, actually that doesn't hold at all in like scenarios I've been in. And so like I like that kind of back and forth. Like it makes you like look at it from a different perspective. So
it's so funny because for the people who are listening, we're talking about like, can I say it?
Sure.
Can I say what that back and forth was about?
Oh yeah, go ahead.
We're talking about, if what I'm assuming is a junior developer or somebody who might be sort of stubborn, like if they get stuck and they're afraid to ask for help, how long should they wait before they speak up? And some people, I call it the 2-hour rule. I don't know if that's really what it's called, that's just what I call it. But then there's some people hold to that. But then me, on the other hand, like I throw my team members, even when they're interns, I throw them into the fire. Of course, I support them, obviously, right? I have to. But I throw them into the fire and I let them learn how to build up their own intuition about when they need help. And there's a lot of support that comes with that. I know in those discussions on LinkedIn, you only get so many characters to type it, right? Mm-hmm. But there's a lot that goes into that. You have to be empathetic. You have to learn how to sense when they're under duress and diffuse it and step in and that kind of stuff. And then you have to be able to hire the right kind of person that can work in that kind of environment. And there's a lot that goes into it. But yeah, I think that intuition building is actually my philosophy there.
That's a good way to put it. It's like everything in life. There's no like, it's not like it's clear cut. It's usually like somewhere in there's like kind of like a happy gray area where like it can exist on kind of either side of the line. And like after you wrote that, I was like, well, that is kind of how like I do things. Like I don't set a timer. I saw somebody write, I put a timer. I'm like, I don't put no timer. Like sometimes like you get lost in a problem and I'm like, I get what I call like gotta finish mode. And like, I'm just going to go until I get it. And then like you build the resilience that way. It's much easier like later on to look back and be like, don't sit around stuck on that problem. But like, there's been like many nights where I was up till 2 or 3 a.m. trying to like figure something out. And I'm like, I'm not stopping until I get it. And so I do agree. Like you build up some, like, you definitely build up some resilience, and especially if you have someone to lend their ear, if you are truly stuck. And usually the things that get you stuck, like, are the silliest things. Like I get like, why does this not work? And then it's like, I left one character out or something, and it's always something like that.
One of the things that brought my team productivity to a screeching halt that none of us, it took a while to figure out. We very recently, back in April, we switched off a SQL Server and we went to Postgres. But we had out of 1,800 stored procedures on SQL Server, and we went down to 0 on Postgres because we switched to dynamic queries.
Mm-hmm.
And there were some parts that just weren't working. And we're like, man, we're looking at everything. It is just spot on. Our code is just so meticulous. And it turned out a couple of the fields, Postgres is case sensitive and it normalizes to lowercase. But we had not yet ingrained that into our head. And in those particular instances, we all missed it. Every code review missed it because we didn't understand. But some of the return columns were quoted with uppercases. So they came back into the app as uppercase when everything was trying to link it through a lowercase.
Yeah. Some of that stuff's like the most frustrating. That's one of those things, like, especially about, like, I know I rant about ORMs. Like we use an ORM at work, but I'll rant about ORMs because, like, I was a data analyst for like 5 years. So like I wrote so much SQL, a lot of SQL, Microsoft SQL Server, Postgres, like all sorts of stuff. And so like I find that just easy to manipulate it that way. But like, I always say it's easier to avoid that when you write the SQL, but like with ORMs and stuff, sometimes it's really easy to miss that.
Yeah, for sure.
Hey, Terrence, nice to meet you.
Hey, how's it going? I didn't want to interrupt.
Nice to virtually meet you.
We leave the interrupting for me.
So yeah, Jason, can you tell us a little bit about your software background? Like, how did you get into software, and how did your journey lead you to where you are?
Yeah, I have kind of a weird, I have like a very unorthodox journey. Like I went to undergrad and I studied like biology, and it took me a really long time to graduate. Like I dropped out for a year and worked at like Menards, which is like a Home Depot of the Midwest, and then like I was like, I go back to school, finish up, and then I moved from Wisconsin to out here to Arizona about 11 years ago, and I worked in like marketing and business development for a few years, and did an MBA, and then got done with that. And I'm like, I still don't really know what I want to do. And so I was like, I want to do something more challenging. Like I didn't really enjoy the marketing type stuff that much. And so I kind of got lucky and got a job in an analytics department at like the big healthcare system out here. So I did a lot of like budget analysis and like different financial analysis and clinical analytics and stuff like that. And like kind of meandered through a few roles, like with increasing complexity on the different analyses I worked on and more like data science-y. And then I decided to go back to school and do a master's in machine learning. And that kind of like, I don't know, pointed me more towards the software stuff. Like I was really into the computer vision and deploying models and the ML ops side of things. And so I kind of just like, once I started studying that stuff and more of like the cloud infrastructure and traditional computer science topics and stuff, I was just like, yeah, this is totally what I like. Like I really enjoy it. So I enjoyed that way more than just like training models. And so I just leaned into it. And then ended up at like a government consulting firm doing lots of contracts for the VA, focusing on like some cool computer vision stuff for helping like speed up like veteran disability claims processing. So we worked on some really cool cloud-based stuff for the government for that. And then ended up at another startup just doing Golang development, like kind of lower latency Golang development with some cool microservices, and then to my current gig now, which is like basically just back end Go development and like cloud architecture and system design type stuff. And so, yeah, it's just basically what I nerd out on.
So have you done any front end development?
I've tried on the side and failed pretty miserably. I saw your thing you wrote the other day about, I think I wrote on there about WordPress, I was like, yeah, I could figure this out. And like, I toiled away for a few weeks trying to build my own site. And I was just like, this is hard, man. Like I can see why people, like you have to really devote yourself to it. Like, obviously, like a lot of the computer science fundamentals will translate, and some of the different like software design principles will translate, but like it's just a whole nother world of stuff to learn. And so I just was like, my interest really doesn't lie in that. It's really on the back endy, like optimization, the behind the scenes type stuff. And so I was like, I'm just going to go WordPress. Like, it's not really my thing. So yeah, I just leaned into what I enjoyed.
Yeah, I definitely agree. Like, stay where your strengths are. It doesn't make sense for you to really dive into something you don't really care too much about.
Yeah, for sure. I mean, like if you're interested in something, like it's like, it doesn't feel like you're toiling away. It's like, I always feel like I'm learning something the more I read. And I actually feel like I'm even going like further that way. Like I think like kind of my low key goal is to be like, I don't know, database internals development or working on an operating system or something like that. I just think that like low level stuff is like so cool.
I've always observed, at least at the places I've been, people who knew the data model of the company were less likely to be laid off or replaced than those that don't. Because at that point, you become so valuable because you can troubleshoot through the data model, like just by understanding the data, you know where to look.
Yeah. Yeah. I did like at my previous job, I did a bunch of data engineering stuff to start. Like I did a lot of data engineering stuff in the past before it was like called that, or before it was called analytics engineering. And so when I started hearing those titles, I was like, what is that stuff? It was like stuff I was already doing. And so, yeah, I did a ton of that stuff. I enjoyed that a lot because I agree. Like, I also think like I've written about this before, but like coming from the analytics world, like you spend a lot of time understanding the business domain, like different business verticals. And like, I've seen that missing, like that fundamental understanding of like what your business does or like how you contribute to the business, like financially. I see that missing from a lot of developers. And so I think that's like a strength of coming from working in like, financial analytics and some of the other verticals and stuff. So yeah, I think like trying to tie your work to like, how do I actually affect the bottom line is really important.
So I know you're a huge proponent of learning data structures and algorithms. Can you kind of tell us how you use them on a day-to-day basis?
I'm going to go on mute.
Yeah, I like them. I'm usually pretty clear about this. I like learning them because like I enjoy it and like it's nerdy and it's fun. Like I'm not like writing a radix try every day. Like no one is, right? I mean like usually the stuff I do is like the pretty vanilla stuff, like nested loops I'll untangle with maps, like that type of thing when I spot it in the code base, and I'll make a note of it. One thing I really like to do is and it's kind of a combination of like the software design stuff, is like if I see an opportunity to pull something out that's really inefficient, I'll shim in like an interface for it, and then I can write the test to make sure it's at like the current thing. I know how it functions, and then I can re-implement with something a more efficient implementation using some combination, typically like maps or arrays or whatever, and see it come out better or faster. And then I'll use some like benchmarking. But like I would say like right now, probably the most I would use stuff like that is just like some of those basics, and then I'll write benchmarking tests to just validate kind of my assumptions that, hey, this is actually X% faster, or this is less allocations or less bytes or whatever. So
like what's one of the biggest performance improvements you've brought to the organization?
The current job, I haven't been here super long yet. Probably the biggest one was when I first got here. Like I said, I did a ton of SQL stuff in the past and a lot of like database optimization. And like the generated queries from our ORM were like really bad, really inefficient. And then like our tables didn't have any indexing on them. And so that was one of the first things. And like that wasn't even like in the code. It was just like breaking down like what queries were generated from our ORM, like where our bottlenecks were, and then experimenting with different indexing strategies in the lower environment and seeing how the request latency changed. And so we were able to like, we took some ones that were like querying like huge table scans like very frequently, 1,000, maybe 1,000 times a second, and got them down to where it's like, instead of querying 4,000 records, it was querying 40 or whatever, because it could seek on the index and it was way faster. And so we like got the double win of the time and the less bytes across the wire. So that was probably the biggest win when I first got here, because we had a lot of very slow calls and very slow responses to our mobile client.
So yeah, I heard you just mention like testing, and I know like a lot of newer developers are kind of intimidated by testing, especially like unit tests. So if you would explain to a junior developer what is a unit test and what's a good unit test?
Yeah, I think like a good unit test to me like tests the behavior of something. And so like I know I just finished like, I don't know, you can see my books back there. Like I just finished like Test Driven Development by Kent Beck, and like I really enjoyed it a lot. Yeah, it was really good. Like even though it's like 20, just over 20 years old or whatever, like unit tests, I see a lot of like the misconception is that like you have this like 1-for-1 unit test for like your class or your function, and like your tests are just very like coupled to the structure of your code. And so I like, and this was very illuminating in the book. I already sorted it this way, but the book really drove it home, was that like your test should really be like, here's my interface to my behavior, and then I want to assert that I'm getting my expected output from my behavior. I'm not testing this whole like structure of my actual implementation. And so like that's kind of the freedom of like, I don't know, using the interfaces and things like that, is that you can really like decouple the structure of your code from your tests. So you're like very free to refactor as long as your behavior stays the same. So that's probably like a big one, and that's pretty abstract. I tend to like, for unit testing, I don't know, people get so upset about testing. It's testing, but I think like unit testing your core like domain logic is probably the most important. And then like the other pieces that you kind of keep around the outside via some interface segregation, you can write some integration tests to make sure that these things work properly. I see a lot of stuff where people will mock all these different things. And like the only time I see that being beneficial is like trying to validate some flow, but you can do that with an integration test anyway. With all that mocking, you're really just testing your ability to mock. I mean, it comes in handy sometimes, but like there's a false sense of security, like mocking a database call. Like, I don't know if that code I wrote actually works. I'm just saying that it does in the test. And so
I've seen a lot of false flags on, that's why I don't do mocks at all.
yeah, I've kind of stopped doing them for that reason.
They're useful for like, if you're going to rate limit like the US Postal Service address validation check or something, then it's probably a good idea to mock. And just make sure that you're getting, but man, I think like as you were saying that, my observation, I don't know how accurate it is, but I've observed a bit. People who are writing libraries and frameworks, it's more beneficial to have the granular unit tests.
Yeah.
The people who are writing applications and like software as a service kind of stuff, that's not really infrastructure. It's more beneficial, as you say, to test against your interface or your behavior. And I think what I've tended to see is people who had a utility kind of programming background, when they come in to work on an app, they have that mindset, and then you get a million unit tests and mocks. And it's not, I don't want to get too authoritative. I mean, we're all trying to be influencers, and we're all trying to be the, the authoritative talker here. But in general, they tend to carry that over and not understand the domain that you would approach it differently.
Yeah, for sure. I mean, like if I'm going to write, I have this like after using this ORM, I know I keep circling back to this ORM. After using this ORM, like I want to rewrite the ORM with generics. Because I don't know if you guys use Golang at all, but like, Go's recent generics drop, like you can like all these things that are using reflection and lots of type assertions with interfaces, like generics will speed that up like so much because of the stenciling that it does. And so I'm looking at this ORM package. It's just like, there's a ton of tests, but it's like the code is like reflection,
Yeah.
which is like so slow. And I'm like, I bet I could probably write a slim version of this with generics and it'd be like, 100 times faster.
We went through that with the C# 1.0 transition to 2.0.
Yeah.
When C# got generics.
Yeah, I've been
And
like seeing more and more use cases for it. Initially it was kind of like utility things like to pointer or from pointer. If I don't have to write that for like every type, and so like, but now it's starting to see other areas where like, oh, this is actually like would be really, really powerful right here. Kind of what drove it home was I wrote something about this the other day. It was like Google has this B tree in-memory B tree implementation library, and it's written in Go, and it was pre-generics, and so it took an interface type, and somebody updated it to use generics, and it was like way faster, like 25% faster just from using generics because of it's the compile time check of the type, not the runtime. And so I thought that was really cool.
Yeah, it doesn't have to discover the type, so all that logic just goes away.
Yeah, exactly.
So like for developers that don't understand what a generic is, what is a generic and what is reflection?
Boy, I don't know. Sean probably could do a better job with reflection than me, but generics are like, instead of you can kind of declare a generic type. I don't know. It's hard to say for people who program in other languages because like you can pass it. In Python, you can pass anything into anything. But in like a language like Go, you have to declare your types for everything for the compiler to satisfy the compiler. But you can give it these kind of abstract things like an interface, just an empty interface. But then you have to do a lot of runtime checking or like use reflection to try and determine what the type is. Versus a generic thing, you could say, I want this function can be reused for a bunch of different types, but when I write the code, I declare what type it's going to use. I don't know. I can't explain reflection very well. Sean probably do a better job than me on that.
Yeah. So like on the generics, it would be like saying, I'm going to create a linked list or an array, for example, but I want it to be a number, or I want it to be a string. Right? So if you say that I want it to be a number, then you can't treat it like a string because I don't know Go, but I heard you say that Go does it at compile time. Languages that I'm familiar with, like C#, it does it at runtime. But essentially the result is the same. If you say that this array is going to only hold an array of ints or numbers, right? Then you can't treat it like a string. And if you say it's going to be an array of address, then it won't be treated, like a phone number and so on. So that's essentially what generics is. Reflection, actually one of my favorite topics because I use it so extensively. Basically, if you look at your code has a certain structure. You have functions, you have arguments, you have some kind of structure about what class hierarchy it belongs to and stuff like that. And what happens is reflection is a technology where the compiler or the interpreter, depending on what language you're using, it produces metadata about that. So it becomes a sort of database where if you want to discover certain facts about the code that you're running at the time, you can get the class name, you can get the object name, you can get the parameters and their values, and you can write tools or other stuff to automate it. I do it in TypeScript with decorators to get certain automation behaviors when I'm interfacing with the database or type or GraphQL, so I don't have to write a million lines of code. I write like 5 lines, and then it self-discovers. But that's ultimately what it is. The TLDR is that the compiler or the interpreter produces metadata about the code that's running at the time. and then you can go query it like it's a database and get information about it, and then you can go and make decisions about what you want to do with it. Hopefully I nailed that one.
Yeah, that was good.
Do I pass the interview? Am I hired?
Yeah.
Yeah. All right.
Now just invert this tree real quick.
I am literally, as we speak, doing graph and tree hierarchy traversals in SQL and child roll-ups all the way up to the nth level. And I was literally just telling my coworker today, I'm like, it's taking us 5 weeks, to hell with that 2-hour rule. It's taking us 5 weeks to write this query in SQL. And I wonder if there's a leak code in SQL, because now I'm ready to go compete. But literally, if this was written in Python, I could literally go ask somebody fresh out of coding school or whatever, could you traverse a tree? Yes, great. Here's the problem for you. Do it in Python, and they'd have it done in a day or two. But but if it's SQL, it's like a month or more.
Yeah, some not stuff in like recursive CTEs and stuff are really hard in SQL. It's not as like intuitive in as it is in like a imperative programming language.
I saw that. I don't know who posted it, but I saw it on LinkedIn the other day. It had like the 7 levels of SQL, and like level 7, they had it titled like God mode, and in there was recursive CTEs and hierarchical structures. Mm-hmm. And I'm like, yes, I've reached it.
Yeah, you made it. Yeah. I've only written a few recursive
but
CTEs.
Don't ask me about inner joins level 2.
Yeah. Yeah. I've only done a couple times. I've only used recursive CTEs a couple times. It's like very it's more mind bendy than writing recursion in a different language, in my opinion.
For sure.
So yeah, I just seen a post you made about the benefits of learning the standard library in and out. What made you come up with that?
I don't know, like the Go community is very big on like minimalism and leveraging the standard library, and like I've always just kind of felt that way when I programmed. Like I always felt like a good way for me to learn a language was to like go read the standard library docs. So like I had to learn Kotlin for some server side stuff when I worked at that consulting firm, and so like I read all the Kotlin docs, and I'm like, well, there's a ton of cool stuff in here. It was like different, you could do these different method chaining, these functional operators, and all this cool stuff with collections. Same with Python. Like I did a bunch of data science stuff, but it was like reading the standard library. There's like tons of packages in there that will do a lot of stuff that you need on a day-to-day basis. And so I just, when I grade take homes or I look at different projects that, maybe a recent bootcamp graduate has done, understandably so, there tends to be a really high amount of imports, for pretty much everything. And I think that's pretty common starting out. I mean, I did that with Python, and you end up with, a gazillion dependencies. And I think what prompted it was I got a DM from someone the other day, and he was asking me some questions about, he was trying to write a CLI tool in Python, and one of the packages he was depending on had a dependency that ended up having a security vulnerability. And he was working for a cybersecurity firm. And I told him, I was like, that's like the rule of, like in a SQL, it's like the rule of like a transitive dependency. Like A depends on B and B depends on C, therefore A depends on C. And maybe you didn't even know that. And so that was kind of sort of what prompted that, was to, like Go has a lot of cool stuff for, marshalling and unmarshalling JSON and simple HTTP calls. And it may not be the like most optimized code, but like it works for most stuff. And so I just think like it's a good way for people to learn a language inside and out, is to leverage the standard library.
Like, do you ever have any concerns that, with all these imports, that you might be importing unsecured code? Like you don't know what's in all of these packages.
Yeah, for sure. Yeah, especially, like node modules, it's like, oh, hell, like what's in there? Yeah, I think it's big, even to, rm-rf, that folder. It's like takes your computer a few seconds. That's a lot.
Yeah, interestingly enough, that happened with Angular. Like I think it's Jasmine, or one of the testing libraries, it brought in a package that was compromised. Like somebody logged into the author's account of one of these sub packages, and they inserted some malicious code, and if you got that specific version of the library, you would pull that into your application.
Yeah, and people were doing in Python. It was a big problem. People were like creating packages that were like one character different than like a really popular one, and if people accidentally typoed the import, like they would import this bad package that had kind of a similar interface but had nefarious code underneath. And so yeah, I think it's just like a good practice. I mean, like I obviously not going to roll my own for everything, but I can just like be aware of what you import and like have a somewhat of an idea of what it depends on. On GitHub, it's easy enough to see the dependency graph for popular stuff.
I've almost fallen victim to that one typo off thing. The thing that has always stopped me is like, I'm expecting this package to have 10,000 or more downloads a day, but why is it showing 13?
Yeah. Yeah, the data science community is really bad with that, because everyone's just trying to like sling models and stuff. And so I always try to catch my friends with that stuff and be like, hey, like, take a look at that package. Like either it doesn't have any tests, or you don't even know if it's right, or it's importing like a bunch of random stuff. Like, you can usually avoid that.
I know, Terrence, I know you was about to say something. I didn't mean to cut you off.
No, I was just. It just reminded me of this time when I don't know what package it was, but there was a lot of major tech companies that were relying on this npm package, and then the author just took it down for whatever
The
reason.
left trim. That was the left trim.
Yeah. And then like they were
that.
just like all these services just sort of came tumbling down.
Just about everything in npm.
Yeah,
Maybe like the is odd, isn't that the one in npm? Is odd has like 50 million downloads or something, and it's literally just like one function to determine if something's an odd number. I imported it and made is even, and it was just if not odd.
Yeah, npm is notorious for like I create a new project and I think I'm pulling in 2 packages. Then I go and look at the node modules and I'm like, whoa, how did I end up with how did I get 276 folders of dependencies?
Yeah, for sure. I mean, that was like what scared me the most when I was trying to make like a React app for my site. I was just like, I used like create React app because like I don't do front end development. And like, my gosh, like what's this thing installing on my computer?
Like you could cook eggs on your laptop.
Yeah,
by the
my
time it's done.
MacBook's on fire. You think training like a neural net burns your computer up? Like try
Like this thing
an
better
NPM
be
install.
computing a Bitcoin for that kind of.
Yeah, for sure.
So yeah, I see you got the functional bitch T-shirt on. Isn't that the name of your newsletter?
Yeah, that's my site. Yeah. My babysitter like has like a side hustle where she creates like merchandise and sells it on Amazon. And so I asked her if she could like make me a shirt. So she like got it for me really cheap.
Yeah, can you tell us a little bit about your website and your newsletter?
Yeah, sure. Like I like for a long time I was running this like app on my Raspberry Pi. It was just like on a cron on my Raspberry Pi, and every night at midnight I subscribe to a ton of newsletters because I just like to read what's going on out there. And so I wrote one for myself, and it was just like a RSS scraper. It was one I was just messing around with, like Go's concurrency, just like fan out and grab a bunch of stuff. And so every night I'd run on my Pi and email me a bunch of articles to read, like anything that was new from the last day. And so at some point I was like, I don't know, I'll like stand this up with like an email vendor and just automate it, and like other people might want it, because it just dumps articles too. So I just decided like, hey, I'll make a simple site and put it on there. I had like an old GitHub Pages blog, and I'm like, well, I'll just transfer that over. And then I was like, well, I wouldn't mind like trying to do some other, kind of solopreneur type stuff, like a course or some, different things like that. And I wanted one place to house them all. So I came up with the name and paid a couple different designers on, I don't know how to say it. Is it Fiverr or Fiverr? I'm not sure how to say it. To like come up with the logo until I kind of got like the kind of cool, like retro pixelated, because I'm not like a young, early 20s developer. So old school. But yeah. And so then I just was like, I might as well just like make it a thing, and then I can keep expanding if I want to on different things. And I kind of have one spot to house it all.
Yeah, I know you've developed quite a following on LinkedIn. Can you speak on the importance of like kind of like branding yourself and some of the opportunities you've gotten just from being so visible?
Yeah, sure. I do think it's really it is important nowadays, especially nowadays, because like you see, I always considered LinkedIn is about me, and I see a lot of people do it where it's like about their company, and so like I see LinkedIn as like a place for me to like share my opinions and like my own flavor of things, and not it be tied to where I work. And I think like that's advice that I think a lot of people could take, like starting out or people who are established, because just the industry is so like shaky right now. A lot of like that cheap VC money is drying up, and like companies don't have any other strategy other than to lay people off. And so I think just as a way to kind of like always kind of keep my finger on the pulse of like what's happening, I think I like to just kind of like put my stuff out there and connect with folks and interact with different people. And it got me my job I have now, like, and it got me my job before, my last job. Recruiters reach out to me. Like I didn't even apply to my last two jobs. Like they reached out to me. So I think people undervalue it, and I always go, it's not going to help. But like when you're visible and like people go to your profile and see you've been writing stuff and trying to have a positive impact on the community at large, like it's important.
Except when you're a CTO, no one reaches out to you unless it's to use them for staffing.
Yeah.
Literally, my job solicitations dropped to 0 the minute I put CTO up.
Yeah, everyone wants to help you hire people then. Now, what are your guys' thoughts on that? I mean, like Kevin, you read a lot of stuff, and so do you, Sean. Terrence, I don't even know if we're connected on there.
Probably not. I'm not sure. I mean, I'll peek every once in a while, but I don't post as much as I used to. I should probably start actually back up again.
I go through like spurts, like I'll write a bunch of stuff for a while, and then I'll take a little break because.
Yeah.
I write as the heart motivates. Like, honestly, I write my best content when I'm angry about something. I don't know why. I'm happy.
Passion.
Yeah, that's usually happens for me.
I just don't get any kind of like interaction.
Yeah, I know. I write some posts about like I read something in this book I'm reading, modern. It's like modern computer architecture and organization, and it's about like analytical engine that like Charles Babbage made in the 1800s. And like, this is super cool. So I write a post about it. Nobody cares. I write some posts like bashing on something, and everyone's like, "Hey, no, you're an idiot."
Yeah.
Yeah. Like you see, like most people write those one paragraph sentences. I think that really helps things take off. I guess attention spans have gotten so short that you got to start doing that. But yeah, for me, man, it's been extremely helpful. Like that's how I pretty much have connected with most of the people that I'm connected to on LinkedIn, just writing posts and posting videos. And it's kind of like made recruiters from Microsoft, Amazon, Facebook, Google all reach out to me. I know I wouldn't pass an interview, but at least somebody's looking at me.
Yeah. I interviewed at Facebook last year. I failed it, but I figured I would give it a shot. I do all the studying and stuff, but yeah, I just didn't make it. And then I was just like, I don't want to grind for the interviews like that. I don't like that. It's not fun.
That's tough.
There's nothing. Sorry, I didn't mean to cut you off.
Okay.
No, please.
No, I'm just saying it's a grind. It's a grind. It's definitely a hustle. Like
it's like a job in and of itself.
It's a job, yeah, because you don't know what to expect, and it's like you have a test, but there's no curriculum, or you have like some loosely put together curriculum by somebody from 2017, and you hope that it's current, and you're just like, all right, I got to get to this much leak code, and I got to have a job by this time, and it's like, it's tough. You don't know what to expect. It's very stressful. And then you don't end up doing any of the stuff that you've studied, like stacks and queues and arrays, and it's changes color to blue, or have this state in React, and click on this and make an API call, and you're like, where's my algos?
What I find difficult is like the disconnect between like where I'm at right now. When I'm hands-on, I didn't really know JavaScript or TypeScript or Node, but yet I originated a system with it that makes the company millions of dollars now, and then switching over to Svelte and Postgres, two things I didn't also know, and then putting my DevOps person to Kubernetes. All these things none of us knew, but we built an extremely solid business off of what we don't know. But I know the principles of systems design and architecture. I'm a scalability architect by trade. But if I go in and interview, I'll fail most interviews because I'm like, man, where do these questions come from? That's not what I like. Ask me if I could build something from scratch in a really short time that actually delivers value,
Yeah.
But don't ask me why 1 equals 1 in JavaScript, but 1 doesn't equal quoted 1. I mean, it's like,
yeah, I loathe those posts, to be honest. Like when I ask people like, what is the output of this? Like if you have to guess, it's bad.
Yeah.
It's bad code.
The reality is we're not going to write that kind of code. We're going to look at it and say this doesn't work, and we're going to fix it.
Yeah, like I said, like I try to draw a clear line. Like I think computer science fundamentals are important. Like I enjoy learning about them, but like I despise the grinding of leak code. I despise it.
Yeah.
Because I just there's just such a disconnect. If you people would grind software design, we wouldn't have such buggy, crappy systems. You would have stuff that worked. And I try to like tell people when they're starting, like, if you learn all this algorithm stuff, right? If you write horrible spaghetti code, it doesn't matter. Like, if you have very clean abstractions, like you can embrace optimization then, because you can safely refactor behind your interfaces, or these contracts you establish. It's like the kind of standard problem, like how do you implement a linked list? Like you can do it several different ways, but you keep that same abstract data type. I think people really miss the boat on that when they grind that stuff. They really miss it hard.
I have a intern that I'm wanting to convert to full-time pretty soon. And it's so funny. We hired him and it's like, okay, we have this big giant React app and it was not done properly. So we're going to start over again using Svelte and we're going to do it properly. By the way, here's your GitHub repo and it's blank. You're writing the first line of code. And of course I coach him and mentor him along the way. But the most satisfying moment I've had with him so far, and I have these kind of moments with different people along my path. He showed me some code that he was super, super proud of. And I'm looking at it and it's like 250 lines of code. I'm like, what if I told you you can get that done in about 35 lines of code? So I told him the steps. I walked through a design. I said, interpret that design and materialize it. And a couple of days later, he comes back and it's about 45, 50 lines of code. And he was like, just his face is just like the sun is radiating through it. It's like, my gosh, I didn't know that was possible. So I mentor by teaching people how to design, and what you said, you can abstract an interface and then leverage it throughout. Then there's only a handful of ways you could be more productive as a software developer. A, don't write the code in the first place.
Yeah.
B, get someone else to write it. Or C, leverage what you've already written. Or D, just type faster.
Yeah. I really enjoy the software design. The thing that I find funny about that side of the community, right? You get these people who are like diehard leak code, like this is the most important thing on earth, and then you get these people who are like PDD, or you're not a real developer. Like I tend, you know what I mean? Like
deployment, TDD.
Yeah. Mine's test. What is it? TIP, test and prod. I like tend to like read those things and like try to like extract what I think's useful out of them. Like not all the parts are useful, like some of them are, and they're not useful for every situation. So I think people like get intimidated by reading that stuff and be like, oh, I have to follow this now exactly. Domain driven design, I have to follow it to a T. It's like, nah, you can just like you can cherry pick the parts that make your life easier, make your code simpler, more decoupled, like separation of concerns, like kind of all the things you want to shoot for to just make your life easier.
You know where some of that comes from? I'll never forget. This was my eye-opener moment. So many years ago, probably about 2008 or 2009. Somebody, blogs were just becoming famous at the time. Social media wasn't really a thing. And somebody influential wrote, if you write the code that takes the form if X equals true, I won't hire you because that's an indicative that you just don't know how to code. Instead, what he's looking for is if X, right? So a lot of people over the next few months, even people I was working with, they're looking at my code and saying, dude, like, you can totally remove that or do it this way, right? And it's like, where did that attitude come from? But then you see that these influential people will say stuff like, I'm going to take a jab, so hopefully you take this in stride. But, influencers that you look up to are going to say, dude, if you don't ask a question within 2 hours, I don't want you on my team.
Sean really did not like that 2-hour post.
It wasn't personal to you. It's just been going on for weeks. I'm like, man. Anyway, so I think that's where it comes from. We get these people that we look up to, and they tell you what their who they're going to hire you or not hire you based on, and then people turn it into a gospel.
Yeah. That's a good point. Yeah, I call it like dogmatic. Like it's like a dogma. Yeah.
As smart as software developers are, there's kind of like a lot of hive mind in the industry. Like this big guy says it, and everybody goes and stuffs it in the apps, and app turns into a nightmare, and then you got to rebuild it like a year later.
Yeah. I don't remember the article, but I read something a while back. It was like some guy like he was making like $10,000 a month or something on some like ancient PHP thing he wrote that was like one big file and he never changed it. And he was just like, they were like, this code is terrible. And he's like, I don't care. Like it works and I'm making money on it, And I think like people like, I try not to lose sight of that. It's easy to lose sight of that. Like, oh, I need this to be like this perfect design and I need this to be super optimized. And it's like, not really, not really.
Does it work? That's what I ask myself. Like, does it work? Yes. All right, don't touch it. Move on.
I became a CTO. The first thing I quickly realized is that if I value code for my team that works, then I will have a long career as a CTO. But if I keep holding up the process over perfection, then I will not have a long career as a CTO. Because what the execs and the investors look for is results.
Mm-hmm.
Yeah, impact. Yeah, that's all people miss.
So, like, what's some of the good software design tenets, and what are some of the bad ones that you kind of come across?
I don't know. I think domain-driven design is good, but I think certain parts of it. I think like the core like domain model parts of it are really powerful, like entities and aggregates and like value objects and stuff, repositories. I think like that stuff is really powerful and like makes your code like nice and separated. Like it makes you think about what are the things that are, your app is going to do. Because like the kind of core tenet of domain driven design is like, you kind of like try to achieve this parity with the actual language of how like the stuff's going to work. And so like, part of the big books, like a non-business or non-tech person should be able to like read your code or your tests and know like what it's doing. You try to use this human readable language that achieves parity with like the domain. And so I think like I find that stuff really useful. I think clean architecture is really powerful, like keeping that, and those two to me like go together really well. So like keeping kind of the core domain stuff at the center, and like that can only be imported by other things, like it can't import anything else. And keeping your kind of external things on these outer layers, using interfaces, all those kind of things kind of like mesh together like that, and ports and adapters and stuff. They all kind of like try to achieve the same thing, and that's to like protect your domain logic from relying on these external things that it shouldn't care about, and having things outside on the outside rings use your domain logic, but through interfaces. And so I think those like concepts are really powerful.
I wanted to add to that. One advantage of that, by doing that kind of layering and that kind of separation, our current app that we're working on, where I work at, we knew, because we started from scratch, and we knew that along the way we would make decisions. Some people call it technical debt. I just call it like cutting corners. But we knew we'd have to rewrite it, and you don't want to rewrite the whole thing. You want to kind of do it a piece at a time. And I'm the kind of leader that I absolutely make the time and tell my team to go back and rewrite. I mean, we're doing that with our front end, but by separating it through these interfaces and these layers, we have been able to rewrite an entire layer, whether it's the repository switching from SQL Server to Postgres, or changing the database schema under the scene, or changing the service layer, which for us is either the REST JSON or gRPC or the GraphQL part. And you can change one of our experience has been you can change one layer at a time completely wholesale without impacting the rest of the app. So if you change your repository, you're not actually changing your services or your entities and stuff like that.
Yeah.
And we've rewritten the app from essentially from scratch 3 times just by changing these layers one at a time. And it's hard to believe, but I mean, we live it every single day. And that's only because of what you described through the clean architecture and the domain driven. If you isolate if you get your layers and your interfaces right, then you're really buffered against changes. And that goes into tests, something I actually meant to say to much earlier in the conversation. If you test against the input and output, what essentially is the behavior, some people want to write tests directly into one of those layers or more, but then you become a host to that layer and you're missing every assumption of a level that you skipped, but then you're tightly bound to the level that you're directly interfacing. Just capture the input and the output and be done with it.
Yeah.
Make your life easy. But yeah, I wanted to throw that out. That's where your advantage, one of your advantages of this kind of layering and separation, is it allows you to evolve the app in smaller pieces.
100%. Like I'm facing that problem right now. Like what the kind of main project I'm doing right now is like a lot of our billing, like our app is a subscription based, and we use Stripe, is kind of to manage that. But like the code that like interfaces with Stripe is very, very muddy and tangled up, and there's Stripe calls tangled up with database calls, and nothing's separated by interfaces. And so it's like trying to like change that, it's like the only way to know if it worked is to run the whole app and run requests through it, and so I'm splitting that off into a new thing and keeping it nice and clean. So, and that's allowed me to like implement a caching layer and some other things like that. It becomes really trivial when the layers are cleanly, no, I guess not trivial is not the right word. It becomes much easier to work behind those interfaces and know that you can, your other stuff doesn't have to change at all as long as you maintain the interface.
We talk about microservices, and I joke a lot because I like to play around with words to capture different meanings. So here I say we have nanoservices, microservices, and macroservices. And once you get into like microservices, like even like just an example, like billing, most people would say billing would be a microservice, but depending on how detailed it gets, you might split it into different nano services. But I think one of the real power of this level of layering and separation, and then putting it behind these different service granularities, is if you realize one day you make a mistake on some sort of a nano granular level, just put in a new microservice, rewrite it. You know, decide you don't like Go for this particular task, it's better in Python or something, you do it.
Yeah.
And you have so many options when you can break everything apart that way. Now, your
Yeah.
DevOps people might not like all the network hops that go along with it, but you know, you'll like it as a developer for the flexibility.
Yeah, I mean, we don't have any. We do the DevOps at our company because like we don't have dedicated folks. I love DevOps, so like that first job with the first hardcore programming job for the consulting firm, we had somebody, but like we all came on at the same time, and so like I had to like what you said, you had someone on your team do. I had to take over like standing up our Kubernetes clusters and like writing all our CI/CD pipelines and like setting everything up for like running on Kubernetes, and like it was awesome. It was like definitely like I'm like the type of like I want to like jump in, like drink from a fire hose, because like I feel like you learn that way, at least for me. And so
I call it resume driven development.
yeah. Pick a hard tech and like just go all in. Yeah. I'm doing a lot of our Dev stuff now. I'm switching this over. We're not really doing much infrastructure as code at all, so I'm migrating this over to start using CDK for our AWS stuff to provision all of our resources and whatnot. So yeah, I like that kind of stuff. That is so
cool.
Yeah.
I know we got a lot of, junior devs that may be watching. So if y'all can kind of give us a brief synopsis, like what is domain-driven design and what is like aggregates and entities?
Oh yeah, sure. Yeah. So like the kind of core of domain-driven design is like an entity, and like the most distinguishing characteristic of an entity is like it has a unique identifier. And so like a customer, a person could be an entity, and that person may like have a different form in different services. So like in an order service, right, they may be a customer or something. In a marketing outreach service, they may be a lead, but like that unique ID follows them around. They can be represented differently, but they have that continued uniqueness like across bounded context and across time. So, and I tend to think entities is like just the basic core characteristics of the thing. So a person would be, like the attributes about them, their name, date of birth, stuff like that. Where you get into troubles when people start stuffing, a ton of attributes on objects, then all of a sudden you have 100 attributes, and is this, is that, and that gets kind of messy. Aggregates are like the classic example is you have like an entity that's the root. It can be made up of multiple entities and value objects, and it has a core entity that's like the root of it. So the classic example is like a car, and the core entity maybe is the engine, and the unique identifier is maybe the VIN number. But then you can have these other like entities that kind of are composed up to make a car, and so it's an aggregation of objects. Value objects are things that don't have a unique identity, and like a color or a currency or something like that can just be reused and disposed. Like they don't need to be like, have some uniqueness persisted across time. So those are kind of the three major ones, and I use those like a lot. Value objects are great because like an entity, you might do a pointer receiver for methods, but like a value object, you'll just return a copy return a new instance of it. And so like you keep that immutability, you don't have any side effect of like mutating the object. So that makes like, testing and stuff like super easy. You don't accidentally mutate state. I hate when that happens. So
we have a comment from Andy Wong. He says, "Hi, Jason, love your shirt."
Where did I see that? How do you see that?
That's on LinkedIn.
Yeah, Andy's awesome.
Oh yeah, most definitely. So another term that a lot of these developers may not be familiar with, the junior ones, like you mentioned interfaces a lot. So if you could explain them, what is an interface and how are you using it in the context you're speaking about?
Yeah, sure. Interface is like a contract. I consider it like a contract. So it's like a contract of like behavior, or yeah, contract behavior is maybe good to put it. So like the most common way I use it all over the place, but the easiest one for people to think of is like an interface to a database. So like Sean mentioned, like repository. So I'll typically have like a repository interface that's like just called like repository, and the method maybe is like get user by ID, and that method returns, the user object in an error. And so I just have this method signature there in the interface, and then I can implement that in any way I want. So maybe now I have a cache repository, maybe I have a Postgres repository, and then the actual concrete details of querying Postgres or hitting Redis exist in that concrete implementation and still has that same method. So then like I can inject that interface, have my different code places rely on that interface, and know that if it calls that method, it doesn't matter if it's a Postgres one or a Redis or Microsoft SQL Server, that it can call that method and get the results that it expects. It doesn't have to care about how it's implemented. And what that does is like it really decouples your code from your like concrete implementation details. And so like your business logic stuff should not care where you have to retrieve data from. It should just care that it can call something and get the data. And so it really frees you up, like Sean said, to like safely refactor this layer, and have these layers kind of communicate with each other through interfaces. The kind of classic one that people are studying DSA, like I said, is like a linked list interface, right? Like you can have the actual implementation of that be several different ways, but you don't really care about that when you use it. You just care that you can call those methods and it works. And so I consider it like a contract, and a signature is for a contract.
So I know you just mentioned code decoupling. That's kind of like a foundational software engineering concept. What is that though exactly, and what is its benefits?
Yeah, I think like separation of concerns is really like the biggest piece of that. Like I read Dave Farley's Modern Software Engineering book recently, which was really great. Like he talks a lot about that in there, like separation of concerns and like how do you make your code more modular. Like cohesion is a big thing. So like things that kind of go together, belong together. The decoupling part is like kind of like what I was talking about before with the database stuff. So like, let's say like I have some couple of objects and I'm trying to determine some business logic, like decision I'm going to make off of these, but I also have all this like SQL code around them for like getting them and then saving them and stuff. Like all that stuff smashed together. Now I can't really test that decision-making logic on its own. I can only test it now if I run it with the full gambit of the concrete SQL implementation. Whereas if those were fully pulled out and decoupled, like it's so easy then to test that core logic. It doesn't need to depend on those things. By having it all stuff together, you've now made it depend on each other. So that's kind of the biggest thing is like, I see it as testability. The more testing you do, the more you start to see like, and this is really hard to test. Like it's really hard to like test this logic. Like there's probably something up with that. That's usually the way I think about it.
So you kind of mentioned earlier that you dipped into the front end. Like what is kind of the differences you've seen between the back end and the front end development? Like what's kind of difficult to you about the front end?
I don't know. I didn't have a good grasp on like, I don't know, like all the different tooling and stuff, around like CSS, and it was just a lot of overhead for me to learn like how all those different pieces like work together, like or how they should work together. And then on top of that, like everybody uses a framework, and so, it's like how much time did I want to invest in like learning a framework, a opinionated way of doing it. And then like, I tried rolling my own vanilla one with just vanilla JS and like HTML, CSS, and I didn't get very far. I'm like, I kind of getting along the way, but like the amount of time, I don't know, just like getting all those things to like work together properly is just like, I struggled with it.
Don't worry, it's the same way for front end devs in the back end. Like, I think I had a back end task a couple months ago with this one company I'm working for, and I was just like, this is stressful. I don't know how back end devs do this. Like, I can't see anything. I can't click a button. Like, there's no CSS. Like, there's no console. I mean, there is a console, but it's just the same terminal that I'm already looking at already. So
Yeah.
it was a
I definitely have like a major respect for. I think like front end developers get like I think Andy wrote something about this, like a bad rap, like they're not real developers, but like that stuff it's not easy. Like modern web applications are really complex and like do a lot of stuff. Like we have some internal web applications for like our coaches to use, and like they're really complex. So, like they're doing a lot of different stuff, and so like I have a ton of respect for that, because like you're really just like focusing on like a different knowledge domain. That's like it's a lot. Like, you know, when I think about the backend stuff, I'm like, oh, I kind of have a good grasp on like how these things should work together and how to do these different things. But then like that's domain specific. You know, it's not quite the same.
Modern front ends, they have their own back end that's separate from the back end.
Yeah, ours, we have that too. Like I was talking to our lead front end guy the other day because I was just trying to like learn and like absorb, and I was asking him all these questions and stuff, like how the things work, and he was very happy to oblige me. And he's like, oh yeah, we got this like node server that like serves our stuff up, and I was like, you have like a node server behind it? And he's like, yeah. And then we call it. I was like, oh, that's cool.
So, okay, say for example, you start like at a new company. What is your techniques of kind of like learning the code, like exploring the code base? How do you manage that?
I guess it depends like what I guess it depends like what's needed to start. I think like if you try to like learn everything, you're gonna get overwhelmed. You have to like start with kind of one thing or one task and use that as a way to like learn that path through like whatever part of the code base you're in. Especially for like really big companies, you know, it's just too much to try and like learn how every different thing works. So I usually will just like work my way through. I usually try to see if we have any like high level design docs of like the system at large, so I can kind of see how the like from a 10,000 foot view, like the different pieces fit together. And I think that usually helps a lot. Or if they don't have that, I sort of start to map that out for myself, and make a diagram of like, well, okay, like here's the front end of the mobile client. Like, what are the different ways it's calling into the back end, and what are the different services we have? And then just kind of as I work on things, like keep building out that model, so I can see how things fit together. And then like navigating the code base stuff, it's usually like, it depends how clean it is. You know, if it's pretty clean, like it's easy. It should be easy. You know, I do a lot of like grepping around and looking for stuff and just tracing different paths through the app to see what it's doing. Yeah, I don't know if I have a great like one size fit all answer for that. It's just something you have to like work your way up into and get your hands dirty.
How about you, Shonda? You have any particular approaches in breaking down like a new code base?
Yeah. I like to start with understanding its structure first. Like some platforms or some companies, they have their own way of structuring their folders and their files, their naming conventions and stuff. And usually if they name things correctly and they have some sort of a system to it, then through learning that, you can very easily figure out how to find things, if they do well enough. From there, to be honest with you, I was telling this to Terrence not too long ago. The ultimate goal is to get something into production. So you really want to, as quickly as possible, get it on your machine, understand the structure, figure out how it's built, and figure out how it's deployed. And you do that by making a change and running it through the cycle, not by studying the platform, but make a typo, do something, change something from red to blue and get it out. And then you will uncover everything you need to know to getting something deployed. And then from there, it's really just, one feature requirement at a time, one other question at a time, and so on. There's only so much you can independently figure out before you'd need some camaraderie to kind of osmosis and absorb.
Yeah, I will say one thing I do for every single app I work on is like the first thing is when I pull it down is I try to run all the tests. And if I can get all the if it has tests, I try to run all the tests. And that's usually like a tell. I would see this a lot with like take homes that I would grade, and it was like the first thing I would do is like, can I actually build this thing locally and like run it? Like if I can't even do that, like I always see that as a red flag, because like that's a huge part of like every job. Like you've got to pull repos down and be able to run them in some local fashion, whether that's in containers or some code spaces or whatever. Like you got to be able to like run it, and so that's usually the first thing I try to do.
One thing I do, so when we onboard people, I believe that part of the experience of enjoying the job is your onboarding process. So we have our team. Anyone that starts here, every account that they need is set up before they start, like about 12 hours or so before they start. And then we have a series of automations. They could literally commit code and have it pushed out to dev on the same day they start. And some of our devs do that. But one thing that we do that I don't know, you would probably love this, is everything we need to do is we have a DevOps folder in the root of our Git repo, and it has a series of bash scripts that are just named after what they do: start, install, connect, establish, cert, security. Like they all have a meaning. You run them, and then boom, within seconds, the whole thing just comes alive on your machine. And I really wish more places would do that, but that's part of what we do. So anyone that comes in, whether you're on a Mac, Windows, or Linux, you just run those scripts and boom, you're up and running.
Yeah, I've started taking that really serious. Because my last job, we had a bunch of we had Java apps, we had Go, Python, we had like all this different stuff, and like the Java apps required a ton of there's a lot of manual steps to get them working on your computer. And I hate that. After having done all that Kubernetes stuff, I was like, why is there not Docker Compose or something, And so like I've even gone even further with my local development. I've been using like Nix. I don't know if you guys are familiar with Nix. I've been using Nix for my local development to have this like really isolated, immutable development environment. And I'll still use Docker and stuff like that. But then like if someone wants to come into the repo, they have like a couple commands. They can either Docker Compose it, or they can, if they want to use Nix, they have like one Nix command, and they have this fully set up development environment with everything that is needed for the app to run. And it's the same stuff the app needs to run up on the cloud. And so I agree, like that is super helpful. And I love setting that stuff up, because it will 10x your productivity.
It's easily.
If you have this like very fast, efficient, isolated development environment that anybody can jump in. And we would like put these, like you said, like these common scripts. Like I will have a make file typically, and like have the same, no matter what the app was written in, the make file will have the same commands, like make test, make build, whatever. And that way, like you can come in and you can, no matter what app you're in, you could type these commands and like have it do these things. And like it's a huge help.
We take it one step further even from that. We built I gave my junior DevOps person, we were talking, I'm like, you know what a service mesh is? He's like, I'm at lunch, let's talk later. He comes back and he went and studied up, and he's like, yeah. And I'm like, it would be cool if we had a service mesh. 12 weeks later, I don't hear from the guy for 12 weeks. I'm like, dude, what's going on? He's like, check this out, Sean. So he, through Kubernetes and all that stuff, and we set it up so our microservices are all running up in the cloud. But through this system of commands, if you want to redirect a request for one specific or more specific microservice to run local, then it'll redirect the whole flow to your machine and then call that microservice instead. So when you're doing development or troubleshooting or anything, and I mean, it's a real joy. Like some of the people that we hire, everyone uses their own laptop until pretty soon we'll start providing them. But right now they use their own. And some of these machines are like not powerful enough to run as many microservices as we have.
Yeah.
So that's like a lifesaver. They're all running in the cloud, but the one that you want, like just set up, just run your sh command and boom, there it is.
Kubernetes is awesome for that. So like we don't use Kubernetes in my current job, but like that job where I used it and set it up, I did something similar, maybe not quite as sophisticated, but like I had a series of like scripts that would like port forward the services up on the cluster to my local one. And so then like I could test my local one at will against the other stuff I had running in like the staging environment. And it like was just so fast for development.
Yeah.
It's so easy.
So true. We have a multi-tenant, so depending on who's logging in, they actually get a different copy. Like we have one copy of the web, we have one copy of all the APIs. We have a different database and a different caching server to isolate the data. And so to run multi-tenant through this system, I mean, you should see the code and everything that they did to set it up. It is just mind-boggling, and it's so beautiful what you can do with Kubernetes and that kind of Istio, Nginx, and I mean that stuff can solve some problems.
Yeah,
it can create some also, but it can
there's definitely some overhead. Yeah, there's definitely some like cognitive load to like get to that place.
I'm a few weeks away from adding a third DevOps just because of the maintenance behind it.
Yeah, like DevOps stuff is fun. Like we've kind of I've been wanting to experiment more with like the serverless pattern of like an API gateway in front of Lambdas, where like you're in using clean architecture, you basically like each endpoint is a Lambda, and so your endpoints scale independently, and they're just behind a gateway. But I haven't like fully gone for it yet. I've been using like AWS ECS like Fargate, and then using some of the other like serverless tooling, and just using some of the traditional stuff because it just is easy. And I like I said, we don't have a dedicated DevOps person, and Kubernetes would be a pretty big lift for us to take on.
I feel like I made a mistake early on. I insisted on not adapting a Lambda style architecture, and I get those bills every month, and I'm like, man, that's as much as a full-time mid-level engineer just keeping these AWS things going.
Yeah.
And I'm like, I can seriously reduce that if I switch over to a Lambda architecture.
Yeah, that's the beauty of that is like, right, if it's not being used, you're not paying for anything versus like, you know, you have this whole ECS or I'm sorry, EC2 pool under your Kubernetes, and like same with ECS. So that's why I'm moving stuff to Fargate, because it's like I can scale down to one task, and then it can auto scale up quickly. I've been switching stuff to testing out some serverless Aurora, like the serverless Postgres, because our app is very like cyclical in usage. Like it's a personal training app, so it's like in the morning people are working out, so the traffic peaks. People are working out in the evening, the traffic peaks, and so like other times of the day it's low, and so you're paying to have all this stuff up all the time, and it's really expensive, especially stuff that has EC2 pools is so expensive.
How's your experience been converting your endpoints from something more traditionally hosted to Fargate?
Like switching the services? Like
I don't know how to frame the question, but in my case, I'm trying to pick your brain because this is something I'm going to be going through. Right now, all of our APIs are on Node, and we're just running it on EC2. Right. Like, what's your experience with converting that over to Fargate?
Oh, sure. Yeah. I did a bunch of Elastic Container. I think it's called Elastic Container. It's like I think it is actually an abstraction on Kubernetes. It's like an easier way to deploy the apps. And so you can either pick to have an EC2 pool, and then your ECS will like manage, sort of like Kubernetes will. It'll manage like where you're at, if it has enough resources for your app to run. Fargate's nice because you just say in the CDK code, it's even easier, right? I say I want this to use Fargate, and there's certain like CPU memory tiers you can pick. And so that's all you have to declare. You say, I want this to be like 512 and 1024 for CPU and memory for a task. And when it hits 40 or 50% CPU, like scale it up a task or two. And then like Fargate will handle the provisioning of the compute. Like you don't have to care what the EC2 machine is underneath it; it'll do it for you. And so yeah, it's been awesome. Like
That's so
and
cool.
then we have the API gateway in front of it too, and I learned some cool stuff about how to set up some proxy routing on there, which is pretty neat. But yeah, it's been cool. I like it a lot. I like my last job. We used Beanstalk, which is like where you actually deploy onto the EC2 machine, and then like each machine is like a node. I mean, like after coming from Kubernetes, I felt like going to the Stone Age doing that, and so I was like, why are we doing that?
We started on Beanstalk and we had so many issues and we just couldn't figure out how to resolve them. It was so hidden behind AWS.
Yeah,
And so our DevOps person originated as an AWS specialist to help us figure out what to do. And yeah, we want to move over to Lambda, that kind of an architecture.
I'd like to move. Probably the next project I might try that, because like there's a serverless application model toolkit for AWS that'll do that. And you can do like canary deployments with your lambdas and all sorts of cool stuff. Like awesome.
That's the kind of stuff that tickles my funny bone. It's like I
Yeah,
love automation and infrastructure. A lot of people don't know this. Systems design isn't about coding as much as it is about infrastructure. When you start talking about scale and application capability and load, you literally are at the very heart of working with just about everything that AWS or like Azure and such does.
Yeah.
You know, and it's like if you want to learn how to scale a system, then become an AWS specialist because that puts you right at the heart of it.
Yeah. What I love about that Lambda design is like where like basically your handlers are their own Lambdas, is that like that's the scalability becomes like near infinite, because what the thing with your other service, right, is like if one endpoint starts getting completely hammered, the whole service has to scale, versus like just that one Lambda has to scale for the endpoint.
Yeah.
And so it's just like such a cool way to let the infrastructure fan out for the concurrency versus like your code having to fan out concurrency. I really think that paradigm is just really cool.
Yeah, I know we're kind of approaching an hour and 30 minutes. Did any of y'all have any like last thoughts?
I mean, I usually have a lot of thoughts, but nothing comes to mind. We covered a lot of stuff.
Man, yeah, we definitely appreciate you coming on, man. You can come back anytime.
Yeah, thanks for having me, fellas. It was a lot of fun.
Oh yeah, definitely a great conversation. Thanks everybody for tuning in. We'll catch y'all next time. Good night.